Today, we're going to go ahead and talk about observational studies. So, this is another category of experimental design. And unlike controlled experiments, in observational studies, the researcher actually has no control over who gets the treatment and who doesn't. So, observational studies are actually done out of necessity. They're not random and they're not ideal.
So you talked a lot about experimental design, but why would you ever need to do an observational study?
Great question. So, our goal in experimental design, we know, is to keep our treatment group and our control group as alike as possible. And I just said that observational studies aren't ideal. So, Wade asked, why would we ever do these? And actually, sometimes it can be unethical to assign people to a specific treatment, especially if you know that it causes your subjects harm.
Do you have an example?
Yeah, so a classic example that people always give is if you're studying pregnancy and alcohol consumption. We know that if
You
you're
don't want to tell a
pregnant,
pregnant woman to drink.
yes, exactly. You should not be drinking when you're pregnant. So, for the sake of your study, it's unethical to go ahead and assign those people to a treatment and then also assign people to a control. So, that would be an example.
But you might find out some women did drink when they were pregnant, and then you can put them in that treatment group or the control group.
Yes, exactly. So in observational studies, the researcher just kind of observes something that naturally happens. So some women do choose to drink when they're pregnant, and then they would be in the treatment group. And then those who chose not to would actually be in the control group. And as you can imagine, there's going to be a lot of differences between those two groups. So the problem with observational studies is that they can show correlation, but it's very difficult to show causation, like we can see with randomized controlled experiments, because of the fact that they aren't random and that our two groups are going to be different, um, probably in a lot of different ways.
Do you have an example?
Yeah, so let's go ahead and do an example of an observational study. So, some observational studies show that people who carry lighters are more likely to get lung cancer than people who don't. So the question is in any experiment is does something work? So are these lighters causing lung cancer? And because this was an observational study, I'm going to go ahead and say maybe, or there could be something called a confounder. And a confounder is actually a difference between the treatment and control group. So in this case, our treatment group would be the people who carry lighters. And then our control group, remember, is the comparison group. So, wait, what would the control group be here?
So I would think it's just people who don't carry lighters.
Yeah, exactly. That would be our comparison group. So, we want these to be as alike as possible, but in observational studies, they're not. So, those differences are called confounders, and they can mix up our results. So, we could actually list, if we wanted to, a lot of times when I'm thinking, okay, what could be a confounder in my study? We can list the differences between those who carry lighters and those who don't, and then see if that could be the true cause of the lung cancer. So, with this example, can you think of any differences?
So someone who carries a lighter, they might be a pyromaniac.
Yeah, they might love fire. Okay, so they might be a pyro
They
and
might be a smoker.
they might be a smoker, right? These people are more likely to smoke. There's probably other ones too, but those are good. Let's go ahead and go with these. And so I want to know, could either of these things be causing the lung cancer? Because both are related to carrying lighters. So when doing these problems, it's always good to first identify, okay, what are your treatment and control groups? And then what is your response? So the lung cancer in this case is our response. This is what we're seeing at the end of the study. And so I'm going to use a diagram to kind of help me organize all of this information. So we have our treatment, which is lighters, and our response, which is lung cancer. And we're trying to see how they are related. Is there just a correlation, or can we say lighters cause lung cancer? But we think these might be possible confounders. So I'm going to go ahead. I'll go ahead and do smoking first. So I'll put smoking in the middle. Is smoking causing lung cancer? Smoking is a known cause of lung cancer. So I'm going to go ahead and draw an arrow saying, okay, the smoking we know causes lung cancer. And if you smoke, we know that you're more likely to carry a lighter as well. So I'm going to draw an arrow in the opposite direction saying people who smoke are more likely to carry lighters. So this would be a classic example of a confounder. So both arrows in my diagram are going in opposite directions. And this confounder of smoking is making it look like the lighters cause lung cancer. But actually, when they investigated the study, the lighters weren't causing the lung cancer. Instead, the lighters were just a marker for people who smoked. And that was the true cause of lung cancer.
So if we do the same example with pyros or something else, how would this
Yeah.
look?
Yeah, so we could do the exact same thing with our other variable that we thought could be a confounder, because you could have multiple confounders, or you could have no confounders. But we have, again, our treatment on this side, our response on this side for my diagram. And I'm going to put the thing that I suspect to be a confounder in the middle, which is being a pyro. And I want to draw my arrows. So if you're a pyro, we said, again, that you're more likely to carry a lighter,
So there'd be
right?
an arrow between pyro and lighters.
Yes, exactly. Um, if you're a pyro, does that cause you to get lung cancer?
I don't know of any research that suggests that.
Yeah, as far as I know, no. So I'm going to go ahead and put just a question mark here. And because we're trying to figure out how are lighters related to lung cancer, this wouldn't be considered a confounder because it actually has nothing to do with lung cancer. So we said at the start of this example, the question was, do the lighters cause lung cancer? And we said, no, there's actually this confounder. But sometimes, this is rare, sometimes in observational studies, our treatment can cause the response. Again, this is rare because we usually have a lot of differences between the two groups. There are usually confounders. But if that was the case, I'm going to go ahead and draw the diagram of what that would look like. So again, we have our lighters, our treatment, and our response, which is lung cancer. And if the treatment truly did cause the response, our arrows would actually all go in the same direction. So the lighters would lead to, there would be something about the lighters that causes the lung cancer. And this box, it wouldn't be a confounder. I like to call it a causal link. And a causal link explains how or why our treatment causes the response.
So I don't know if this research exists, but maybe the chemicals inside the lighter might be related to lung cancer. So the lighters have chemicals are going in the box, and then the chemicals cause the lung cancer.
That is actually a great example, Wade. It's usually, our causal link is usually something about the treatment. So like the chemicals in the lighters, that's what's causing the lung cancer. And again, I don't know if that's the case, but that would be a great example of a causal link. Or if your treatment is a drug or a pill, a lot of times the causal link is an ingredient in the pill. It's something about the treatment that actually causes the response. So here there's this direct relationship. And we see this with randomized controlled experiments. But with observational studies, oftentimes what you'll find is that there's these confounders kind of mixing up our results. And the last thing that I want to say about this is you've probably heard me say this. Statisticians are always saying correlation doesn't imply causation.
It's a classic phrase.
Yep, exactly. And this is really important when you're reading studies because we don't want to tell people that lighters cause lung cancer if they don't. Instead, we always want to think about those possible confounders. If you know a lot about the treatment and the response, a lot of times it's easier to come up with them. You can list differences between the treatment and control groups to kind of try and think of what could be confounding your results. But a lot of times it might not even be obvious what the confounders are. So that correlation does not imply causation is the key part of this video. You never want to say that when you have an observational study because confounders could exist.
Awesome.